Hi everyone, this is a video that will go along with what we learned today, and that is solving a system of equations. So what is a system? A system is two or more linear equations, and your job is to solve to find where the lines intersect, also called the point of intersection, the POI. Sometimes there's no intersection, that's when we have our parallel lines. There are 4 ways to solve the system, and you need to know how to do all 4. You can certainly choose which one you use on the test, but being familiar and confident with all 4 is definitely going to help you. The first one we're going to talk about is the equal values method. The equal values method is the one that you will most likely see often, and it's the one that you are actually the most familiar with, even though you don't really know what it's called. So the way that it works is if you have y is equal to 3x plus 5 and then y is equal to x plus 9, the y value is the same for both of those equations. So you have 2 equations that are both equal to y. And what that means is since they are both equal to this y, they are actually equal to each other. So you can set the equation, the 3x plus 5 and the x plus 9, equal to each other, and then solve. And if you take a look at this, this is something that you've actually been doing a long time. So that's why it is the one that feels the most familiar. So let's go ahead and give it a try. Okay, so what we're going to do is we're going to solve this equation for x. So I'm going to move this x, that's my intentional 0. Remembering that you have to show every single step, and you only do one step at a time. This is imperative for success on the test. Making our intentional 0 here, and that means we have 2x is equal to 14, and we divide by 2, showing everything, and we get x is equal to 7, or at least that's what we think. So now what we want to do is we want to go ahead and we want to use the first of our 2 equations right here, back to the original always, to find the value of y. So we're going to have y is equal to 3x plus 5. And we want to find y when x is equal to 7. So we're going to have y is equal to 3 times 7 plus 5. Y is equal to 21 plus 5. And we think that our y value is 26. Okay, so the next step is to actually take both of our y and our x value that we've come up with, that we think our point of intersection is, and we're going to use this second equation and we're going to check. So our check is going to be, we are checking when x is 7 and y is 26, which is what we hope is going to be the case. We're using y is equal to x plus 19. So we have 26 is equal to 7 plus 19, and 26 would equal 26, and that is a true statement. So yes, so the point of intersection, so the POI for this system, remember, you have to write it in parentheses with a comma, is 726, using our equal values method. Okay, so if you are asked to take 2 lines, and by using graphing, you are going to want to start with one or the other. It doesn't matter. I'm going to start with the one where I say one color in red, and I'm going to start, again, at the y-intercept right here. And that's where I'm going to put my first dot. So that first dot is going to be right here at that 5, 0, 5. And then the next thing you want to do is you want to do your rise over run. Please notice it's negative, so your line is decreasing, right? So we're going to go ahead, we're going to go down 1, and then we're going to go over 2. We're going to put a dot rather. Down 1 over 2, down 1 over 2, and down 1 over 2, I'll stop right there. And then I'm going to go backwards, up 1 over 2, up 1 over 2, up 1 over 2, and that should be enough. So again, I don't have notability, so please excuse my not very straight line. So I'm going to connect my dots, and I'm going to go all the way through my graph, remembering to put some arrows there. So there we go. That's my first line. Now I'm going to go ahead with my different color. I'm going to use blue this time. And there's nothing, right? There's no plus or minus. and this would be our rise over run. There's no plus or minus because it's 0, and that's over 1. So, excuse me, we're going to start right here. And now I'm going to use my rise over run. So I'm going to go up 2, and I'm going to go over 1. And then I'm going to go up 2 and over 1. There is my point of intersection. Up 2 over 1 again, up 2 over 1. And I'm going to come back here and just go down a little bit just to get my nice straight line. And I'm going to draw that all the way through again. Boom. And as you can clearly see, this right here is my point of intersection. And that is going to be 2, 4. Now, you could go ahead and you could solve this using the equal values method just to double check. I'm not going to do that. Next way to solve a system is by using something called substitution, which you have known how to do for a long time. Excuse me. In this example, in our first equation, I want you to notice that it's solved for y. We have y equals all of this information right here. And you have a y variable here. So what we're doing is we're taking this and we're putting it in where the y value is. And lo and behold, we end up with this, which is using the distributive property, ladies and gentlemen, which you are used to using. So let's go ahead and solve that. So here we are. We're going to go ahead and we're going to solve this. I have put in a box our original equation. So I'm going to use that distributive property, and I'm going to distribute the 5. So I have negative 5x minus 35 plus 3x is equal to negative 13. I'm going to combine these two to get negative 2x minus 35 is going to be equal to negative 13. I'm going to create my intentional 0 right here. Negative 2x is equal to 22. I'm going to divide by negative 2 on each side, and I'm going to get x is equal to negative 11, or at least I hope. I'm not done. I have to go back into my original equation, and I have to solve for y. I'm using this one because it is already solved for y. So I am going to use y is equal to negative x minus 7, and I want to solve that when x is equal to negative 11. Y is equal to negative 11. Be careful. Y is equal to 11 minus 7, and I am hoping that y is equal to 4. All right, so now I'm going to go back into this equation. I'm going to put both in. This is my check. So my check. I am checking when x is negative 11 and y is hopefully 4. So I have 5y plus 3x is equal to negative 13. So I'm going to have 5 times 4 plus 3 times negative 11 is equal to negative 13. And I have 20 minus 33 is equal to negative 13, and negative 13 is equal to negative 13. So my point of intersection for this system of equations is negative 11, positive 4. The elimination method is, I think, the hardest one, but of course that's just my opinion. Some of you may actually like it. The main idea behind the elimination method is to add the two equations together so that you eliminate one of the variables. That's what our goal is. So let's give this one a try. So we're going to actually solve this equation by adding them together. We're going to do the stack add. You can see that this is our intentional 0. That's why we've been so intentional, of really kind of forcing you guys to understand what that looks like. So 2 and 5 is 7x, and that's going to equal 14. And then we divide by 7 on each side, and we get x is equal to 2. So that is our first value. And then again, we have to come into one of the two of these. We'll just pick the top one. It doesn't matter. And we're going to have 2x plus 3y is equal to negative 2 when x is equal to 2. So 2 times 2 plus 3y is equal to negative 2. So you're solving for y here. 4 plus 3y is equal to negative 2. We're going to make an intentional 0. And we have 3y is equal to negative 6. Divide by 3. And this time y is equal to negative 2. So I'm going to use my second equation, and I'm going to do my check when I have 2, negative 2. So I have 5x minus 3y is equal to 16. So I have 5 times 2 minus 3 times a negative 2 is equal to 16. I have 10 minus a minus, so that's a minus 6 equals 16. So two negatives make a positive. I have 10 plus 6 is equal to 16, and 16 does in fact equal 16, so this is correct. So your point of intersection is 2, negative 2. Okay, so this is not a slide that was in your original slide deck, so you'll have to just excuse me for not having it ready. But what I want to talk about on this slide is what happens when you just can't add the two together to eliminate one of the variables. For instance, if you were to go ahead and you were to add these two together, you would not eliminate the x because you'd get 4x, and you would not eliminate the y, you'd end up with plus y. So that's certainly not going to work. So what you have to do is you have to somehow manipulate one or both of the equations so that when you do add them together, you end up canceling. So what do you look for? So a little kind of list of things to look for. So one of the things that you want to look for are variables that are negative and positive. So if you can look for variables that are negative and positive, that's the ones you're going to want to attack. The second thing you want to look at is easy multiplication. Okay, so looking at our criteria, if we look at the very first criteria here, which is number 1, it's easy to see that our negative and positive falls into our y. So that's criteria number 1. Criteria number 2, easy multiplication. There's a 1 in front of this and there's a 2 in front of that. We can easily multiply that first equation by 2 and have a negative 2y, and then we can add them together and we can eliminate that variable. Okay, so let's go ahead and do that. So the first thing that we want to do is we're going to alter this equation. We're going to multiply or distribute, if you will, a 2 into every single part of the equation. And then what we're going to do is rewrite the equation. So we are going to end up with 6x minus 2y is going to be equal to 4. I always double check, did I get everything? Yes. We'll bring down our other equation, x plus 2y, and that equals 3. And now you can clearly see when we go on, we add these two together, what ends up happening? We have these variables that are going to end up canceling each other. So let's go ahead and move forward. So we end up with 7x is going to be equal to 7. Isn't that lovely? We're going to divide by the coefficient, and we're going to get x is equal to 1. Lovely. So now what we have to do is we have to go back in, and this is so important, you guys. You must go back into that original equation. You cannot go back into the equation that you have altered ever and find your additional value. So you can use either one. I'm just going to use the top one. So I'm going to have 3x minus y equals 2, and that is when x is equal to 1. I'm solving for y. So I have 3 times 1 minus y is equal to 2. I have 3 minus y is equal to 2. I'm going to subtract 3. There's your 0. Minus 3. I'm going to have negative y is equal to negative 1. And from the previous problem, you know I have to divide by negative 1. So I end up with y is equal to 1. Or at least that's what I hope. So now I'm going to go ahead and I'm going to use this one to check. So I'm going to check when I have, hopefully, a POI of 1 and 1. So I'm going to write down my original equation. X is equal to 2y plus 3. I'm going to have 1 plus 2 times 1 equals 3. And I have 1 plus 2 equals 3. And I have 3 is equal to 3. And yes, indeed, my POI is equal to 1 comma 1. All right, that's it. I did also send along a couple of problems I want you to work on, and there's also a key.